Okay, last video of this section. Okay, it's sum and, there's no multiplication that we have to do here. It's, there's not a product to multiply out. It's just sum or difference of terms. But we can do some simplification here first. So that's going to be 4/3 x to the negative 3/5. The 4 and the 3, just a coefficient, bring it off to the side. I don't like things in the denominator. If I can get rid of them in the denominator just by using a negative exponent, that's what I do. The index is my denominator. The power is my numerator. And then I've got 6 sine 1/5 x minus 7 cotangent x, that's cosecant x, cotangent x, minus 7 cosecant x, cotangent x, minus 2 to the 4x, and then that's going to be 8 times 1 over 1 plus x squared dx. So just written in a little more friendly format, and now I can use my basic rules. The 4/3, just coefficient just stays there. Increase the exponent by 1. Negative 3/5 plus 1 gives us that 2/5. Multiply by the reciprocal of the new exponent. Increase the exponent by 1, multiply by the reciprocal of the new exponent. The 6 just stays there. Linear angle, linear argument. The effect of that 1/5 will be to divide by it or to multiply by the reciprocal. So 5 over 1. Then I ask myself, what has a derivative of positive sign? What has a derivative of positive sign? And that's going to be negative cosine. And then the angle does not change. But I have to be really careful about the SIGN here, positive and negative. What has a derivative of positive sign? Well, cosine in general, the derivative of cosine in general is negative. So I got to compensate for that by putting a negative out in front. The 7 is just a coefficient. Then the same thing again. Be careful about the sign. So I'm not looking at the negative 7. I'm just looking at the cotangent. And I'm asking myself, what has a derivative of positive cotangent? What has a derivative of positive cotangent? And that's going to be, what has a derivative? I said wrong thing. So I'm not looking at the 7, or the negative 7, just looking at the cosecant cotangent. And so I ask myself, what has a derivative of positive cosecant cotangent? What has a derivative of positive cosecant cotangent? And that's going to be negative cotangent. No, that's not. We're going to get it right. Let's try again. So pretend that previous 30 seconds didn't count, didn't exist, didn't happen. Okay, so not looking at the negative 7. I just wrote that down. Coefficients just hang out. Then thinking about the cosecant. We'll get it right. Cosecant, cotangent. We will get it right this time. What has a derivative of positive cosecant, cotangent? What has a derivative of positive cosecant, cotangent? And that's going to be negative cosecant. You've got to get those pluses and minuses right. Then on the end, a general exponential. When I differentiate, it's times the natural log of the base. So I'm going to divide by the natural log of the base. Then the effect of that 4 gives me a 1/4. And then exponentials essentially repeat as long as we have a linear exponent. And then on the end, I should have written smaller. The 8 just hangs out. Then you're asking yourself, what has a derivative of 1 over 1 plus x squared? And that's tan inverse of x plus c. And then we just make it look prettier. The 4 and the 2 cancel, leaving 2. So I have 10/3 x to the 2/5 minus 30 cosine x over 5 plus 7 cosecant x minus 2 to the 4x over 4 natural log of 2 plus 8 tan inverse of x plus c. And then if you have the time and the space, you can check those things by differentiation. Now, a lot of these you could check by just looking at this. You should be able to check that one by just looking at it. Should be able to check that term by just looking at it. Check that one just by looking at it. Check that one just by looking at it. This one you probably need a little more than just looking at it, but a lot of these you could check just by looking at them. Okay, next one. It's a fraction. I cannot do fractions directly. It's quotient. Must, for now, must simplify to non-quotient until we get some other techniques, and we will get, not so much in this, there'll be a few techniques that comes more in calculus 2 where you get lots of choices for fractions. But right now, you got to simplify it to a non-quotient. There are only 3 fractions you like, and we'll write that down. Must simplify to a non-quotient except for 1 over x. We're okay with that one. 1 over the square root of a squared minus x squared, because that was sine inverse, and 1 over a squared plus x squared. That's the natural log of x. That's sine inverse x over a, and that's 1 over a tan inverse of x over a. Those are the 3 fractions that we're okay with right now. That ain't one of the 3 fractions, so we've got to simplify it. And let's recall, I'm going to go on to a new piece of paper. One term in denominator. What we have frequently done, that's worked frequently, is split up. So that's going to be 4 over t to the 1/2 plus t to the 1/2 over t to the 1/2 minus t cubed over t to the 1/2 dt. And so that's 4t to the minus 1/2 plus 1. Numerator, denominator, same, so plus 1. Minus t to the 5/2. And where that 5/2 came from, 3 minus 1/2. In a fraction, I subtract my exponents. And now it's in a much more calculus-friendly format. And so now I'm ready to find my derivative, or find my antiderivative, find my integral. And I should have said this before, but I'll say it now because I thought about it now. When you go to find your antiderivative, when you go to actually integrate, find your integral, find your indefinite integral, that's when you drop both the integral sign and the dt. Someone always asks me, what happened to the dt? The integral sign and the dt are the things that say, integrate now, please. And once you integrate, you drop them. Just like when you have the square root of 9 is 3, you drop the square root sign because you did it. These things are telling me, find the integral now, and then once I find them, I will drop them. So now I'm going to find my antiderivative, so I'm going to drop my integral symbol, I'm going to drop my dt, because I don't need it anymore, and I'm going to use my basic rules. Increase the exponent by 1, multiply by the reciprocal of the new exponent. The antiderivative of constant is the constant times the variable, so 1t. Then increase the exponent by 1, multiply by the reciprocal of the new exponent, plus c, and let's make that look a little bit prettier, 8t to the 1/2 plus t minus 2/7 t to the 7/2 plus c. Now let's check that. So I've got the space. differentiating. So multiply by the exponent, decrease the exponent by 1. Derivative of t would be 1. Multiply by the exponent, decrease the exponent by 1. Derivative of that 0, or derivative of plus c would be 0. So I'm going to have 4 over t to the 1/2 plus 1 minus t to the 5/2. And it will check back to here more or less, or check back right to here. You can't check your algebra from here to here, here to here. It's not going to check your algebra, but it's checking this step right here. When I went and found my antiderivative, it checks back, and it absolutely checks back, so I know I'm right. If you got a few minutes, check these things. Okay, last problem. We'll see if we can get it done in the 4 minutes I have left for this video. If not, we'll get a real short video. You only know 6 trig integrals, excuse me. That doesn't look like one of the 6 trig integrals. And so we've got to rewrite to known trig forms. And when I see that, the only thing I can think of to do, because there's no obvious trigonometry here. I don't see anything like sine squared plus cosine squared. Since there's no obvious trig, the only thing I could think to do on this one is to go to terms of sine and cosine, because there was no other obvious trig. And now let's clear the fractions. Clear the individual fractions. I'm going to multiply all the terms by sine. So sine theta, sine theta, sine theta. So in the numerator, that cancels, leaving 1. Down below, I'm going to get 1 minus sine squared theta d theta. Okay, it's a little prettier, but it's still not one of the trig I know. But now there's some obvious trigonometry here. All of us should know that 1 minus sine squared is cosine squared. We all should absolutely know that. You've got to know those basic Pythagorean trig identities. All of us should know that. And then more basic trigonometry. 1 over cosine is secant. And so this is secant squared theta. And there I have achieved what I said I needed to do first. I need to rewrite to known trig forms. That is a known trig form. And so now I can just ask myself, what has a derivative of secant squared? Well, tangent has a derivative of secant squared, and then I throw on the plus c. Now this one, checking, only checks this last step. There is no good way to check our algebra and trigonometry leading up to the secant squared. And so checking here is just going to check this last step. And that is the end of this section in this chapter.